All right, today we're going to look at lesson 6.6, add and subtract inequalities. The next couple lessons are just about inequalities, and they're solved very similar to equations. And so that way, it's going in that sense, it's going to be kind of easy because it'll seem kind of like review. But there are some things, a little bit nuances, things that are a little bit tough. So first thing we want to talk about is what is an inequality? Well, inequality is exactly kind of what it sounds like, not equal, not necessarily equal. And this is where we talk about our greater thans and our less thans, greater than or equal to, less than or equal to. Why do I use inequalities instead of equal? Because in the world we live in, a lot of times things don't have to be exact. For example, if you go to the store and you want to buy something that's $5, you don't need to have exactly $5. You can have $6, and that's fine. 7, 8, 10, 20, $100, and you can buy that thing, right? So it's not that you need exactly $5. You just need to have $5 or more, and that's where inequalities come in. So it's important for us to understand what inequalities are and how they're used. So first, I want to start with like a little table we're going to draw, and then to put in our notes, and just to give us a little bit of definition here. So I'm going to just make a quick table, and you can copy this down in your notes. Okay, let's start with this symbol. This symbol stands for less than. And I'm going to talk about graphing, what that kind of graph looks like. And I'm going to use some terms that won't make sense until we start actually graphing. But this is going to be called open circle or open dot. Okay. This is going to be arrow to the left. And so you'll end up looking something like that. Okay. So this is less than. Now these are a little bit misleading. This is assuming that the variable is all the way on the right side. Okay, but it is, or sorry, the variable's on the left side, so we're reading all there. But I'll show you some instances where it could flip over and still be less than. All right, the counterpart to less than is then, of course, greater than. All right, so here we have greater than. You're going to have again, you're going to have an open dot, and that'll make more sense once we do the graphing. And this time you're going to have the arrow to the right. Okay, so you've seen this before. For example, when we talk about less than and greater than, we see that all the time. You have to be greater than, 48 inches to ride this ride. You might see that at the carnival or at the Disneyland or something like that. Let's say you can have, if you only have $20, then you can spend less than $20, right? I mean, you can spend up to $20, but you said I need to have some change left over, then you can spend less than that. So we're comparing things. We have less than, we have greater than. Okay, very similar are these two symbols. So we will, this is less than, and to make this very evident, I'm going to put this line underneath. Okay, what this stands for, very important here, is this is what we call less than or equal to. Okay, less than or equal to. So for example, that example I just said, you have $20. You have $20. Your mom says, "Here's $20. You're going to go to the mall," and you say, "Here's $20," and that's all you have. Well, then you can spend exactly 20, equal to 20, or anything less than that. You can spend $19. You can spend $10. You can spend $5. Right? You can spend anything that's less than or equal to $20. Right? This will be a closed circle. Okay, closed dot. And this one is still arrow to the left. So it's going to look like this, a closed dot, arrow going that way. And then next, the counterpart, of course, is greater than or equal to. Okay. So, for example, you might hear someone say, "I need at least 3 volunteers." Well, that means I need 3 people, or 4, or 5, or 6, or 7. I mean, at least, so it could be greater than that. All right, so this is going to be greater than or equal to. This will be still closed dot, and this one will be arrow to the right. And why arrow to the right? Because again, the greater numbers are to the right. Right? The bigger number is always to the right on the number line. So some other words that might be helpful when you see these things. You might see something like, for this one, you might see words like at least, right? On the flip side, you might see at most here, right? Like if I can spend at most $20, then everything else is less than. If I can spend I need at least 3 volunteers, then it's 3 is my lowest, and I can go only up, right? So those are some words that might be helpful too. At least and at most, some terms that can be helpful. Greater than, and more than, or above, or things like that. Those are the kind of words you might see for greater than, less than, below, or less than, simply, right? So those ones will be a little easier to tell. Okay, so let's go ahead and get into it. Hopefully you're able to comment all that down. So again, we're going to talk about this dots and these close and opens and things like that. All right, so let's do an example here. Let's talk about graphing first. What does it mean to graph these types of problems? Okay, so first, real simple. X is greater than 5. Now, you might see it, or rather, is this the same thing? Are these two the same? 5 is less than x, x is greater than 5. The answer, of course, is yes, these are the same. Now, how do you know? Look where the open part is going, okay, towards the x. The open mouth is going towards the x. In this case, the open mouth is going towards the x. So that's where I was talking about how it's a little bit confusing in this chart about like, well, can greater than be less than? I always like to say you read it from the variable, okay? So the variable. So this would be x is greater than 5. And then this one would be x is greater than 5, okay? So I would read it from the variable, have the variable be your starting point, okay? X is greater than 5, or x is greater than 5, okay? Okay, so what do? Let's go ahead and graph these. These actually aren't too bad. So let's go ahead and draw a number line. And I'm going to put right in the middle, I'm going to put the number 5. Why 5? Because 5 is my number of choice, right? And I can do a couple of dots after. It's really not important. The only number you really need is that 5, but I'll just show you here. So this would be 6, 7, and 8. This would be 4, 3, and 2. Okay, so x is greater than 5. So let me ask this question. Can x be 5? Well, no, but first of all, sorry, let's say, can x be 6? Well, yeah, x could be 6, so I'll put a dot up here. Could x be 7? Sure. How about 8? Yep. How about 7.5? Yep. 6.5? 6.8. 5.2. As you can see, I could just keep putting dots here. And what happens if I put all these dots here? I end up with a line. A line that goes on forever. Now the question is, where does that line stop? The line stops at 5. Could x be 5? Is 5 greater than 5? No, it's not. So what we do is we put an open circle at the 5. What does that mean? That means the 5 is our starting point, but it can't actually be an answer. It's like it's not actually a dot. So if you saw earlier when I was kind of putting dots on all these different numbers, right? I was putting dots on all these different numbers. Well, I can't put a dot at 5, but that is my starting point. So even 5.000001 is okay. 5 is not. So that's all I have to do for graphing. Let's try another one here. Y is less than or equal to -3. All right, so what are we going to do? We draw a number line. We put -3 right in the middle. Okay, so first thing, should it be an open or a closed? Okay, open or closed? Well, again, we have this equal to, so could it be -3? Yes, -3 could be an answer. And then we see that it's less than, right? So we can look back at our table. Less than means it's a closed dot and the arrow goes to the left because that's where the smaller numbers are, right? Here's -4, here's -5. So we're going to do this. And it goes that way. That's how you graph these. Again, open or closed, right, is based off of that equal to. Could y be -3? The answer is yes. On this one, yes. On the other one, letter A, it could not be 5. So we put a closed dot. That signifies that it is part of the solution. It is a possible answer. So is -4, so is -5, so is -6, so on and so forth forever. And so you end up with a line going this way. Now, this is how I know that I did it right. I can double check. Let's try a number on the other side. For example, here's -2. Is -2 less than or equal to -3? No, it's greater than. So I shouldn't have anything there. All right. Don't worry, you'll get the hang of those. Now let's do solving and graphing. So 2 skills here. Now what's great about this is these are solved just like the equations that we did in lessons 6.1, 2, 3, 4, and 5, right? All the lessons before. So let's go ahead and just jump right in. A plus 1 is greater than or equal to a positive 3. A plus 1 is greater than or equal to a positive 3. Okay, so same thing. Let's draw the wall. We see we have a plus 1, so let's subtract 1 on both sides. And we have A is greater than or equal to. Now, sometimes people just automatically kind of like muscle memory, they put just an equal sign, so make sure you keep the inequality. A is greater than or equal to 2. So now let's graph it. Draw the number line. Here's our 2. We have an equal to sign here. So it's going to be a closed dot. And it's greater than, so it's going to go to the right. If you really want to check it, okay, you can choose a number, anything on the right side of 2. So let's choose a number. Let's try 4. This should be an answer. It should work. Let's check it. Okay. So this is what I'm going to do. Here's my original problem. A plus 1 is greater than or equal to 3. Instead of A, I'm going to put 4. 4 plus 1, is that greater than or equal to 3? Yeah, that's 5. 5 is greater than 3. So yeah, that's a possible solution. That works. So there's 2 parts. There's finding the solution, and then there's graphing. And what's great about this is the next couple lessons are going to be multiplication, division, and then 2-steppers. So it's all solved really the same way. It's just now, again, there's kind of an infinite amount of answers. And so you have to do this graphing part that kind of shows that you know that there's going to be a lot more answers. Let's try one more. 10 is greater than b minus 5. Okay. So let's go ahead and do this one. This one's a little bit tricky because the variable's on the other side. All right, draw my wall. I say, okay, I see a plus 5 because that's minus 5. And I'm left with 15 greater than b. Now, if this is a little bit confusing to you, you're allowed to flip it over. That's what I would maybe like to do is kind of flip it over. Just make sure when you flip it that the sign, everything flips correctly. What do I mean by that? So let's flip this over. I'm going to put the b over here. I'm going to put the 15 over here. Now notice the arrow is pointing towards the b. So I'm going to make sure the arrow points towards the b on this one. right? You don't have to do this step. If you can understand it without flipping it, that's totally fine. But I like the variable on the left side, so I'll keep it that way. The only risk is sometimes people forget to flip everything over, okay? So again, the open mouth is going towards the 15, so make sure the open mouth is going towards the 15. Okay, so let's go ahead and graph this one. Here's 15. Okay, open or closed? Well, I don't see an equal to, so I know it's going to be open. And arrow is going to the left, so a less than, so it's going to be this. Now, sometimes I hear people saying, well, it's easy to decide right or left. You just kind of follow the arrow, right? Well, this is an example where you shouldn't do that because if you notice, okay, if you try to follow the arrow on this one, right, the arrow is pointing to the right, but we end up going to the left. So again, you need to read it from the variable. This is b is less than 15, okay? B is less than 15. B is less than 15. B is less than 15. Make sure you're going the correct direction, right? Okay, so this is how you find the solution, and this is the graph. Those are things that you'll need to try and do, and make sure you understand how to do those as you graph them and as you find these solutions. All right, and that's all we got.